Let's test the Zoom quickly. Okay. Yep. Yep. Okay. Okay. Anyone know what calculus is? Does anyone know what are you learning calculus? Limits. Okay. Sounds too fancy. I don't know what, a lot of people might not know what that is. Yeah, in the back? Derivative. What in the world is a derivative? Anyone know that? Yeah. Area under the curve. Okay, now we're getting at something more understandable. Areas we know. It turns out that'll be Calc 2. We'll know how to do that. There. Series. Yeah, that's actually Calc 3. That's true. Good. So let's see. What about the basics? Okay, so what is calculus? Well, really, it comes from the word like calculating, Latin, meaning small pebble. So why is calculus anything to do with pebbles? Well, it's back then where they don't have computers and calculators. Thousands of years ago, you use pebbles, right? You use pebbles, like you have like these like little pebble boards to just calculate, how many things that you have, right? Very primitive, but it's just the idea of calculating something. That's what it's coming from. Okay, but what are we actually going to study? So let's see. So geometry. What do we study in geometry? We study something. We study what? What kind of things do we study in geometry? Shapes. What is it? Shapes, right? We study shapes. What shapes? Matthew? Okay. Right, we know what we study in geometry. Okay, what about algebra? We study something. What do we study in algebra?
Equations.
Angle, that's like more trigonometry, right? And equations, right? Equations, right? Equations, there's an equal sign and you solve for something. Right? You study equations. Remind me your name?
Yeah.
Okay. And Sandra. Okay. So in calculus, what do we study is it's really the mathematics of change and how something changes, right? How a function changes, how any process evolves, right? How a radioactive element decays and changes, how a moving car, starts accelerating to get from one place to another, right? Its speed is changing, its acceleration is changing, its position is changing. So anything that undergoes any kind of a change, which is pretty much everything, right? Calculus is what we use to study it, right? We use calculus to quantify those changes. So right, so profit, right? Someone that's doing economics, profit changes with respect to change in price, right? So economists use calculus where they track the stock or or their stock portfolio or the business revenue or the business profits, right? Based on other factors, right? So they want to know how their profits are changing, how the value of their portfolio is changing. So maximizing profit, minimizing cost are calculus problems. Okay. Calculus is what you need, is the type of math that you need to solve these types of problems. Anything that undergoes any kind of change and you want to quantify, an economist will care about maximization and minimization, right? In terms of physics, right? What will physicists study? Well, physicists will study, like, let's say, particles moving, and they'll have a certain position with respect to time, right? They'll have a position with respect to time. So when you have position, and the particle is changing positions, there are the changes that happen are, you can look at the velocity of the particle, study the acceleration of the particle. Okay, so in Calc 1 will let you figure out, like, if you have position of a particle or the position of anything, calculus will tell you the velocity at every time. Like if you have a complicated movement where something speeds up, slows down, you can quantify that and get the velocity at every moment. And if you have the velocity, you can then get the acceleration, right? So quantifying any kinds of changes that undergo a particle or any kind of a movement is a calculus problem, right? Calculus will let you quantify changes to get things very precise. Okay, and those of you that are in computer science, where does calculus come in? Well, if you're doing things like machine learning, and you're basically trying to minimize an error between training data versus your synthetic data that your algorithm is generating, and you're trying to generate something that's matching observed training data, right? And to get that kind of a match, you're trying to minimize an error function. So a lot of these computer learning algorithms that you study are made to minimize an error function, and that's done with calculus. Anything that's changing, you're trying to minimize something, will be done with calculus as well. Okay, so that's the idea, that's the rough idea, the kind of math we want, is we want to quantify anything that's undergoing change. Okay. Okay, so first we're just going to do a review. We're going to spend a couple lectures just reviewing pre-calc, just reviewing algebra. Okay, the most important parts of it that you'll need for this course. Okay, so that's what we're going to start out with. Any questions on this kind of rough little outline that I'm making? You know, I don't want to introduce anything mathy yet. So you have a rough idea. Is that okay? Just a rough idea of what we're doing. Okay. But any signs that you're dealing with, if you're curious and how calculus applies to bio or econ, then feel free to ask me about that. Because I'll only have sort of select examples, but students want to see examples from calculus in biology, calculus in chemistry. Let me know so I can change my examples a little bit. Okay, so the first thing we'll need is functions, just a very basic. Okay, so functions we have y equals f of x. Y is a function of something else. So what does that mean? So two quantities, y and x, might be related. So a function describes a relationship between two things. Might be related with y determined by x. Okay. So what's an example? Suppose I want to calculate areas of a circle that have a certain radius. Well, the radius is related to the area, isn't it? Right, so you have two quantities that are related to each other. So what is the area of a circle? Okay. Pi r squared. And remember your name? Layla? Okay. So don't get annoyed, guys, if I ask your name. I'll be asking quite often because it's going to take me a while. 33 students. I'll know pretty much all of you after the first exam, all the names, but it'll take a little while. Okay, like Layla said, it's pi r squared. So because they depend on each other, I write a of r. So r is the input, and the output is a, which is the area. Okay, for any radius that you put in, your output is going to give you the area for that circle. Okay. Here's another example of a function. So say y is your revenue for selling, doesn't really matter. Let's see, iPhones, that keeps changing. X is the number of iPhones. How much does an iPhone cost now? Isn't there a new one coming out? How much are they now?
1,000.
Is it over 1,000 yet?
Yeah.
Definitely over 1,000. It's not 1,500 yet, right?
Yeah. I mean, if you want extra gigs.
Extra gigs. What about I want the basic cheapest thing I can get with my wallet. What is it?
800.
800? Okay. But a new version. Will it still be a new version?
No.
Oh, that's like, it's an old version?
Yeah.
Okay. Okay, let's go with 800. Keep getting really pricey. So the revenue is going to be related, right, to the number that you sell. So let's see. If I sell 0 iPhones, how much will I have? 0. Okay, if I sell 1, how much will I have? Let's see, if I'm at 800, then I'll have 800. If I sell 2, how many will I have? 1,600, and 3, 2,400. Okay, does anyone see, since they're clearly related, right? X and Y are clearly related. Can I write it as an equation? Y of X is equal to what? Does anyone see the relationship? Y of X, which is the revenue, what function is that? Someone hasn't spoken in the back.
Times 800.
X times 800. Okay. And your name? And Selena? Okay. X times 800. Yes, so do you guys see 0, 1, 2, 3? It matches. Okay. And we should even graph it. So we don't really have negative iPhones here. So I guess I could graph it. And this is, what kind of a graph will this look like if I try? What does this look like? linear, right? It'll look like a line, right? It'll look like a line, and it'll be 1 is 800, 2, 1600. Now, it's a little bit debatable if this is a good way to graph it, just because what does it mean to have half an iPhone or 1.5 of an iPhone? So that could be subject to interpretation, right? You'll have to decide in this case whether it even makes sense. But at least for the whole numbers, 1, 2, 3, 4, 5, 6, it does make sense. And this is a little bit of a graphical representation. Okay. So what happens here is 0, 1, 2, 3. You could think of 0, 1, 2, 3 as like the set of input data. Input data going into your function. And all these numbers, 800, 1600, 2400, you could think of it as the set of output data. That's all the outputs. That's all the possible, let's say, Y values that you're going to have. Right? So X values inputs, Y values are outputs. So that's really what a function is, definition. So a function from the set A to the set B is a correspondence that assigns to each element in set A. Set A is called the input or independent variable. Okay. Okay. A unique. So you take a certain value of X, you take a certain input, and you get a unique element in set B, which is the output, called the output. Okay, so here we have, so a set A are all the different X's, the number of iPhones, like 0, 1, 2, 3, 4, 5. These are all the X's that we could input. And we take one of the X's, and there's a set B of all the outputs. And in the iPhone example, the possible outputs were like 0, 800, 1600. Okay, so a function, f of x, or if you want to call it y of x, takes an input and then spits out an output. Okay, exactly one output depending on the problem. Here, the output was revenue for the iPhones. Okay, so this is like the mathy definition. As long as you understand that we have the x variable, which is independent, that's the input, and then the output, which is f of x. Okay, but notice that in iPhone example, does it make sense to do x less than 0? Could our inputs be less than 0? Why not?
We can't have a negative number of items.
Right, we don't have a negative number of iPhones. So just sort of the physics of the situation are not letting us plug in any input. Like in this function, 800x, It's true, it does make sense for plugging in negative X values. Like you could plug it in. But the output doesn't make sense just because we're talking about the number of iPhones. So just the physics of the situation, X less than 0 doesn't make sense. Makes sense. So we restrict to X greater than or equal to 0. Okay. Yeah, question?
Order iPhones though, right?
You can pre-order. Oh, so maybe that's like a negative iPhone.
You could owe someone an iPhone in the future.
That's true. That's true. That's a good point. We could think of negative iPhones as you owe somebody iPhones. You have like a negative revenue, right? Because you owe somebody an iPhone. Okay. So if we want to allow that, that's true, right? You could think of negative iPhones in that situation, right? So you have to sort of evaluate the situation and see like what makes sense for, let's say, this business model. So let's say here we won't allow the pre-order. So then this will make sense. And then if we do allow the pre-order, then as Layla said, we could allow X less than 0 for pre-orders. Okay. Should we allow half iPhones?
No.
Yeah, it's a little bit weird. So we could even restrict further. So restrict to X equals 0, 1, 2, 3, etc. Okay. So see, now that we've assessed the situation, the only inputs that we have, we're going to allow here are 0, 1, 2, 3. And if we allow pre-orders, we'll allow even negative numbers. But once we've assessed that, this set of numbers is called the domain of the function f of x. Right, the domain are all the inputs that we're going to allow. Right, so in the iPhone example, it's true that this function, I could plug in any number for x, but it just doesn't make sense physically. So these are all our inputs. That's what a domain is. So let me write that down. So the domain of f of x is the set of all, it's a set of all inputs. Right. You guys see how domain are x values, things that we could plug in, right? We won't have fractional iPhones, right? iPhones will be whole numbers. Okay, 0, 1, 2, 3. So in this example, so if it's an iPhone example, is equal to 800x, right? We know we're dealing with iPhone, then the domain, right, is you're going to write a set x equals 0, 1, 2, 3. Okay, but let's say I don't say that this is iPhones. I just give you a function, f of x is equal to 800x. And I ask you for the domain. Now, if they don't tell you any physics in the example, what that means is they're asking you for something called the natural domain, i.e., natural domain. And what the natural domain is, just all the X values, all the inputs that you could possibly plug in without getting into trouble. So i.e., all possible inputs, X values, i.e. X values, you can plug in without getting into what we call trouble, right? What does it mean, trouble? Trouble is, well, you just start plugging in X values and see if there's a problem. Like, if I plug in 0, is there any problem, 800 times 0? If I plug in 1.5, is there any problem? Can I multiply 100 times, can I multiply 800 times 1.5?
Yeah.
Yeah, does anything go wrong if I try to multiply like that? Right, nothing goes wrong. What about negative numbers? 800 times -1, what is that? Negative 800, okay, nothing wrong with that. 800 times -0.5? Negative 400. So plugging in negative numbers, also nothing goes wrong, right? Okay, is there any X value where like something goes crazy wrong mathematically?
You mean imagine a complex number?
Complex numbers? Yeah, that's true. What's your name? Luigi? Yeah, technically you could do complex analysis, and it is okay to plug in complex numbers. We just won't do that here. So there is a way to make that work, but you would have to take a complex analysis course. But we're going to stick to just what are called real numbers, right? So they're not complex. Yeah, so just in terms of the real numbers, nothing is giving us trouble. So what's the domain? The domain is all real numbers. All real numbers. Okay. And that's a perfect answer. If you want to know what to put into WebAssign, what WebAssign is looking for is it wants negative infinity to infinity. So it's a set notation. It's an interval notation. You're going to have to write negative infinity to infinity means all real numbers. All the numbers between negative infinity to positive infinity. But put open parentheses, not closed parentheses. Okay. Yeah, make sure you're putting in the open parentheses. Okay, questions on this? So either one is actually going to be fine. Yeah, any questions in the back? Yeah, give a thumbs up if we're still together. Okay. Who's ready to go home? Okay. All right, let's plow through a little bit. Okay, is this pace okay for you guys? Okay, you can follow along a little bit. Okay. Okay, so when will we have trouble? So let's see, what are the ways we could have trouble? There are ways we could have trouble. F of X is equal to, let's say, radical X. Okay, now we have to go back to our minds to pre-calculus, to algebra. Okay, we learned radicals at some point, they do something. Okay, what's radical 0? Can I plug in 0? Can I take radical 0?
0.
Radical 0 is 0. Okay, that's fine. Radical 1? 1. Can I take radical of a half?
Yeah.
Yeah, it's hard to compute, but I could. Can I take radical -1 and get a real number? No, does it make sense? Is there like radical -2?
No.
Radical -2.5, right? Or will my calculator give me an error?
Yeah.
Or give me an error, right? So that's what the trouble is, right? We're talking about trouble. So it's X values that give you trouble. Okay. Right, so what's the domain? Meaning the domain is the non-trouble, right? The way you could think of it is non-trouble X values. Right, there's trouble. The domain is the opposite of trouble, is X values that don't give you any trouble. So what are all the X values that don't give us trouble?
From 0 to +.
0 to plus infinity. Selena, is that what you were going to say? 0 to plus infinity. That's right. So you could just write X is greater than or equal to 0. That's it. On an exam, perfectly fine. You could write that. Even better is if you write like the set notation, but I'm not picky. So if you want to be really particular, a domain is a set. So that's what these squigglies mean. They mean a set. So all the X values that are greater than or equal to 0. If you write X greater than or equal to 0, that's perfectly fine. Not a problem. Okay. All right, we can go with that. Let's see, WebAssign, X greater than or equal to 0, what you're going to have to do for WebAssign as an interval, you have to do 0, close parentheses. It has to be closed because it's including 0. If you're including 0, you have to do close parentheses, guys. Until where? Plus infinity. That would be your answer for WebAssign. Any questions on, yeah.
I was gonna ask like maybe later, not right now, if you don't want to, like, go over like the questions from like this.
Yeah, something like, yeah, I'm gonna get to like the more complicated homework examples. We're building up there. Yeah, we will. Yeah.
We also allowed to use this thing on the test. Like
But
this
which
or
one?
whatever.
This one?
Yeah.
Yeah, any of these three are fine on an exam. Like, as long as I understand it, any of these three are perfect, however you want to write. Good, other questions? Okay, radicals can get us into trouble. Let's see, what other trouble can we get? F of X is equal to, how about 1 over X minus 1? 1 over X minus 1. Now, think about all the numbers you could plug in. Go ahead. What's your name? Matthew, yeah?
You can't plug in 1.
We can't plug in 1. Well, why not? What's gonna happen if we plug in 1?
0,
0 in the,
we can't divide number 0.
right, we can't divide.
Yeah.
Mhm. It's undefined, right? It's undefined. What's your name? Raphael. Sapphire? Sapphire? Okay. Tell me your name again.
Yeah.
And Becca, right? Okay. Yeah, so like Sapphire is saying, if you try to plug in 1 minus 1 is 1 over 0 is undefined. So that's trouble. Right, that's trouble. Can I plug in other numbers like -1?
Yeah.
Can I plug in 0?
Yeah.
Right, 3, 3.5,
Any numbers except 1.
any number except 1. Will I get into trouble by plugging in any other number? Right, I won't. Right, I won't get into trouble by plugging in any other number. So remember the domain is the opposite of trouble, right? Trouble is bad inputs, domain is good. So you should think of domain as good. Don't get confused between trouble and domain. Domain is the good stuff, not the trouble stuff.
Wouldn't there be also asymptote at 0?
Yeah, it would be in terms of graphing it. Yes, there would be an asymptote. There would be an asymptote. That's in terms of graphing it. and sort of the semantics of what that graph looks like. But in terms of numbers I could plug in, I can plug in 1.001 without a problem. So in terms of the domain, what could you write? X not equal to 1. It's fine. I'll get full credit for that. X not equal to 1. Another way to write it, X, so it says X not equal to 1, right? Standard math textbook would write it like this. In terms of WebAssign, they're not letting you write it like this. So in WebAssign, what you're going to have to do is you're going to have to write it as
Minus infinity to 1.
negative infinity to 1, exactly, comma, or a cup. They let you do a cup, or you can do a comma. It should accept the comma. Comma what? Negative infinity to 1,
1, 2 plus
1 to plus infinity, but make sure it's parentheses, open parentheses here. Right? Open parentheses mean not 1. Open parentheses here mean not 1. Okay. So be very careful on the WebAssign on whether you're putting closed or open parentheses. Other kinds of trouble you could have. F of x is equal to ln of x minus 1. Something that you guys have to remember from your pre-calc is you can't take ln of numbers less than or equal to 0. I can't take ln of numbers that are below 0, including 0. Okay. See, this is the graph of ln. Graph of ln is like this. So number at 0, it's undefined, and below 0, it's not defined. Okay. So now I have to think about your inputs right now. If I plug in x equals 1, what am I going to get?
stroke. It's probably
Yeah. If I plug in the Jackie?
Fine.
Undefined, because if I plug in x equal to 1, I'll get ln of 0, right? Can I plug in 2?
Yeah.
2 is okay. Can I plug in 1.5?
Yeah.
Because if I'm plugging in numbers like 1.5 and 2, ln of a positive number is fine. But what if I plug in x equals like a half? Then it'll be ln of
stroke.
negative a half. I can't do that. I can't take ln of negative numbers. So the trouble, when you see ln, the trouble starts if you're starting to take ln of negative numbers or 0. So you have to remember that from pre-calc, that when you're dealing with ln, you can only take ln of positive numbers. Okay.
Domain will be 1 to plus infinity.
That's right. So domain, like Becca is saying, is x greater than or equal to 1. What is it?
It's not equal to, it's only greater than.
That's right. Good. So can I, if I put an equal to ln of 0, it won't work. So you'll actually have to make it greater than. Good. Matthew, is that what you were going to say? It'll actually only be greater than. So now, do I need a closed parentheses or an open parentheses?
Open.
Open, right? So it has to be an open parentheses for this to work. Okay, so just a little bit of a trick on all these problems. So the trick is if you see radical g of x, and they're asking you for a domain. You see a radical. I can't take radical of negative numbers. Then you need g of x greater than or equal to 0 for the domain. Right? You need to solve an inequality. Right? You can't end up with negative numbers in the radical. You need the thing, whatever thing you see in a radical, that whole thing has to be positive. Right? That's how you're going to set yourself up. You're going to set yourself up by setting it equal to greater than or equal to positive. If you see, like you see f of x, you see a fraction with g of x in the denominator. Now, if you see a denominator, then set g of x not equal to 0 as part of your domain. Okay, so this won't work for every problem. This just works for most of the problems that you'll see. That radicals will give you trouble, and denominators will give you trouble. Okay, so the domain is the good parts, right? The domain is making sure that the denominator is not 0. The domain is making sure that whatever stuff in the radical is positive. Okay. So let me show you guys an example of that. Is there a question?
Let's just say we see that on the website, we do the homework on, like we couldn't put it in like that.
Yeah, so this is just to get you started. It doesn't solve the problem. This doesn't actually solve the problem. This is to get you started. Now we'll see solving this is something that you do in pre-calc. This is called, you'll see it's called a rational or a quadratic inequality. You can just Google quadratic inequality. It's something you do in pre-calc to solve this. So we still have to solve it. Yeah, it doesn't give you the full answer. It gives you something that you'll need to solve. Okay. So as an example, f of x is equal to radical x minus 7. Right, and now we need to know the domain. Right, so the domain, so use this trick. You see something in the radical, so you guys try it first. Use this trick, right? This trick is basically step 1. Whatever you see inside the radical, set it greater than or equal to 0. Set it greater than or equal to 0, and then solve for x. Right, you'll solve for x as an inequality. Okay, you'll have to do a little bit of algebra. So take whatever inside the radical, set it greater than or equal to 0, and then try to solve it.
7 to plus infinity.
7 plus, Jackie, were you going to?
Would it be x greater than or equal to 7?
X greater than or equal to 7, right? Yeah, Jackie, how did you start it? What did you do for this?
Using an algebraic equation, so x minus 7 is greater than or equal to 0.
Right, right. I can't take radical of negatives. So the thing inside has to be greater than or equal to 0. Now I could actually solve for x. And what do I do to solve for x?
Move it to the other side.
Yeah, I can move 7 to the other side. X greater than or equal to 7. Okay. Do you guys see how that works? Okay. Let's just go through this really quick. What's not a function. Right? Everything I showed you guys was a function, but what's not a function? What's not a function is it fails the vertical line test. Is what happens is, remember, a function has to take an input and give you only one unique output. It can't give you two. So that means if you have something that looks like this, right? The vertical line test is you kind of take a pencil across the function and make sure it only goes through one point on the graph as you move the vertical line. But here, as you move your pencil, is it going through 1 point or 2 points? 2 points, it's not a function. That's not a function. What about this one? Is this a function? You just use just with your finger, like a vertical cross. Is it ever intersecting 2 points? So, yes. Is everything else here that we've seen a function? Is this a function? Okay. Yeah, as long as it's f of x on one side is equal to anything with x, that's a function. Right? The only time, these things go wrong is like when there's something pathological. Like if you have f of x squared is equal to, let's say, x squared. Well, this won't really be a function just because if I try to solve for f of x and I take a square root, there are two solutions with a square root. There's a plus and a minus version to solve. So that's not a function because there are multiple outputs that way. Okay. So that won't be a function when I write an equation like this. But as long as it's just f of x on one side by itself, that'll be a function. Right? I'm only getting one output. So little exercise. F of x equals x squared minus 1. Okay, so someone else want to try. Is it a function? First of all, is this a function? Is there anything that looks like it might spit out multiple values? It's a function, yes. Let's see, someone that hasn't spoken, the domain. Go through the list. Participation. Cameron? Is Cameron here? Cameron, what would be the domain here? In other words, are there any x values that give us trouble here?
No.
Right, nothing. Like we can plug in any number, can't we? So what would be the domain?
Negative infinity to positive infinity.
Good, right? Like Cameron saying negative infinity to positive infinity. Okay. Can we plug stuff in? What's f of 2? 3. So 2 squared minus 1. 3. What's your name? Rachel? Okay, like Rachel said. Okay, let's see if we could stump somebody. F of negative 3, how about that? F of negative 3.
8.
8? How'd you do that?
Just negative 3 squared is 9.
Negative 3 squared. Yeah, the squaring is going on the negative. And what do I get? 8. Good. What's your name?
Jonathan.
Jonathan? Okay, let's see. Okay, how about f of t? What's f of t? T squared minus 1. Okay. Okay, what about f of 2 plus h, right? H is some random constant, just represents a number. Matthew?
H squared minus 1.
Okay, and where do I put the squared? So I have two plus h. Do I,
Parentheses and then the outside of the parentheses.
right, good. Parentheses on two plus h. So you guys see that parentheses on two plus h squared and then minus one. Right, you-
Square plus four h minus three.
and Beth is doing, you're foiling it out, right? You're simplifying it, right? Yeah, so you could simplify it as well. But make sure the parentheses on the two plus h. So don't write two plus h squared. That won't be right. Okay. Okay. Fine, so let's try these, more of these domain ones that you see on the WebAssign. So let's do g of x is equal to radical two x minus 11. Okay, take a couple minutes, remember the trick, right? Your step 0 is anything under a radical has to be set greater than or equal to 0. Right, you have to start the inequality and then you have to solve it. You're going to be doing algebra to solve. Let's see, in the back, what's your name? Egget? Is it Egget? How do you want to be called? Egget or Eddie? Egget?
And yeah.
Egget? Okay. Okay, what did you do to solve this one?
So two x minus 11, larger though or equal to 0.
Good,
Move to the other side, so that's two x 11 positive.
Mhm.
Then I'll move 2 on the other side by dividing it by 2 both sides. So x has to be larger or equal to 11 over 2.
right. Greater than or equal to 11 over 2. That's the domain. Does that make sense, guys? Right, that'll make sure x greater than or equal to 11 over 2, just try it. It'll prevent you taking radical of a negative, you know. Pick a number like 20, and then you won't have radical of a negative. Okay, so that's how you're going to do it. Okay. Let's try another one. F of x is equal to 1 over x times x minus 1. Jackie?
And so when we see something like that where it's like x greater than or equal to 11 over 2,
Yeah.
how would we put that in WebAssign?
Yes, good. What would you put into WebAssign? You'd have to do it in interval. You'd have to do 11 over 2 close bracket infinity, which means the same thing. Does that make sense, guys? Right, they represent the same.
5 times how?
Yeah, you could write 5.5 to infinity. WebAssign will accept it as long as you're putting in the radical. I mean the closed parentheses. Okay. Now try this one for the domain. Remember, trouble regions, denominators could give trouble. You don't want denominators to be 0. Go ahead, Matthew.
So the domain cannot be 0 or 1.
0 or 1. Yeah, that's right. So when is the denominator 0? So for the domain, I need x minus 1. I can't have the denominator being 0. Right, and one thing you guys learn in algebra, if you have two things multiplied, set to 0 or set not equal to 0, you can do each one individually. So not equal to 0 means both x is not equal to 0 and x minus 1 is not equal to 0. Right, multiplication like this, you could take each one each piece not equal to 0. So x is not equal to 0 and 1. Okay. Now this is full credit. This is actually a good answer. You know, you could even put squigglies. I love the squigglies. It's a set. Someone realizes that it's a set. That's cool. I'll accept either one, whether you forget the squiggly, whether you don't. Okay. WebAssign doesn't let you do that as much as I like it. Someone see, how do I input that to WebAssign? What do I have to do? One deposit infinity. Yeah, so this means the same thing. See, 0 has parentheses, open parentheses, and 1 has open parentheses. So it means it's not included, right? It's not included in the domain. Okay. Okay, pre-calc review. Okay, emphasize, this might have been a while for you guys. How long has it been since you guys took pre-calc?
3 months.
It's 4 months.
Or months? Has it been a year for anybody? 2 years for anybody? Um, anyone remember what pre-calc was about? Okay, a little bit, maybe. Okay, this is one of the big things that we need in pre-calc that you'll need in the WebAssign. I'll show you in a second how it relates to the domain. Solve x minus 3 over x minus 6 greater than or equal to 0. Solve that. Okay. Now, what does that mean? Right. That means, right, watch very carefully on how to do this. That means you're trying to find all the x values that makes this fraction positive. So like you can plug in x equals like maybe 5. 5 minus 3 is 2. 5 minus 6 is negative 1. So 5 will make it negative. 5 doesn't work. So they're asking me what are all the x values that do work. Okay. Right. Now I'm going to emphasize that this type of problem, you're going to need it on test 1. You're going to need it on test 2. And you're going to need it on the final. Meaning every single exam that you have in this course, you have to know how to solve this type of problem in pre-calc. Okay. It's going to be very important for the course, especially later on. So pay close attention on something that will appear on every exam.
What is the first exam?
Well, I'll have to gauge it. I'll have to gauge it. It kind of depends on the class sometimes, because it could be one lecture off from another class. But I'm going to warn you guys at least 2 weeks in advance. Okay. To solve these inequalities, whatever this looks like, let's make it even more fun. X times x minus 3. Let's make it more fun. Step 1. Something called cut points. You need the cut points. What you're going to do is you're going to set the numerator equal to 0. Set numerator equal to 0 and denominator equal to 0. You're going to set both of them equal to 0 and solve. Okay. So you're going to be doing algebra. X times x minus 3. I'm going to set it equal to 0. Okay. And what's the denominator? X minus 6, I set it equal to right? You're gonna solve each one. You need both. Someone else want to try x times x minus 3. What is x?
0 and 3.
0 and 3. And let's see. We have is it Snea? Snea? What's x here? 6. Okay. Those are the cut points. 0, 3, and 6 are the cut points. Okay. That's how you have to start it. You won't be able to solve this in your head. You have to get the cut points. Question.
Why is the first one 0?
Numerator and denominator? Oh, this one? So that's the numerator. That's the numerator. You have to set the numerator equal to 0. And then when you have multiplication, in order for this to be 0, either x is 0 will make it 0, or x minus 3 is 0 will make it 0. So whenever you have multiplication like that being equal to 0, either one could be 0. Okay, so that's what you're going to do. You have x times x minus 3 equal to 0. So in algebra, we know 0 and 3. Okay, now step 2 is you have to make a number line with the cut points. Make a number line with the cut points. And what I'm going to do is 0, 3, and 6. Okay. Now, when you label these, it's going to help you to label whether something is undefined. So notice that the denominator is undefined at x equals 6. So put a open circle, because 6 cannot be there. It's undefined at 6. So anytime your cut point is coming from a denominator, put an open circle just to remind you that it's not going to be part of the answer. It's not going to work. Okay. And then for the numerator 0 and 3, because it's greater than or equal to 0, that means equals is included. 0 is included.
Closer to.
Yeah, so I'll put a closed circle, because if I plug in 0 and 3 in the numerator, I do get 0. So that'll help me remember that 0 and 3 are included. Yeah, so again, is that okay? Does anyone see why I'm including 0 and 3 here? Because what happens if x equals 0, what do I get here? If x is 0. 0. Am I allowed to be 0? Yeah. If it was just greater than, that means I'm not allowed to be 0. I'll put an open circle. But greater than or equal to, I could be 0. If I plug in 3 in the numerator, what happens? 0. Am I allowed to be 0? Right. Closed circle. Now with this number line, the number line is going to test whether you're whether this whole thing is positive and negative. Now you're going to start plugging in numbers in between the cut points to see if you're positive and negative, right? Because the way the theory works is that if I plug in something here away from the cut point, if it's positive everywhere. If it's negative everywhere, right? The cut points tell you where things could change from positive to negative. So if I'm positive somewhere away from a cut point, I can't just change to negative without going past the cut point. So that's why I could just check one number in between the cut points, and that'll tell me everything. Okay, so here's what I mean. I could pick a simple number in this region, less than 0.
-1.
So yeah, let's just pick something simple. No, -1. Yeah. Okay, if I plug in -1, -1 times -1 minus 3 over -1 minus 6, what do I get in the numerator?
4 divided by -4.
Right. So the numerator is a positive or negative?
Positive.
Positive. Divided by positive or negative? -1 minus 6 is divided by negative. What's a positive divided by negative? Negative. Right? So the cut point tells me that everything here will make it negative. Right? It can't all of a sudden be positive for a different number, because if it is, I'd have to go through a cut point, and there is no cut point. Right? So it's negative everywhere. Okay, so will this be part of my answer? See, all the numbers here will make this negative. Do I want it to be negative? No, I want it to be positive. So these won't be part of my answer. Okay. Take a couple minutes, guys. Test the others. Just test in between the cut points. So maybe someone can start the class off. Well, what should you test between 0 and 3? 1 or 2. You know, don't do a half. I mean, you could. It's annoying, but I have to read that. But you could. Okay. So go ahead and try that, and take a break if you need to. I'll start again at, say, 4:12. Okay, so we'll resume at 4:12. If you need a break, or if you need to ask any questions, let me know.
Yeah.
this side.
Okay, guys, so first of all, just raise your hands. Were you guys able to figure out, who was able to figure out in between? Okay. So what we do in between, similar thing. Plug one into whatever thing you're trying to solve, which is here. So plug one into x times x minus 3 over x minus 6. So you just plug it in, you just want to know if it's positive or negative. So if I plug one in, I get 1 times 1 minus 3, positive or negative? 1 times 1 minus 3 divided by 1 minus 6. So negative, and 1 minus 6 is negative. So negative divided by negative, positive. So that means, since I already know my cut points, everything has to be positive here. Okay, just try it. Any number you plug in, cut point magic tells you that it'll be positive. Right? That's the idea of the cut points. It cuts off where you can go from positive to negative. Okay, between 3 and 6, tell me a nice number.
5.
5. If I plug in 5, I get 5, 5 minus 3, 5 minus 6. So numerator is positive or negative?
Positive.
Positive. Denominator, 5 minus 6 is
Negative.
positive divided by negative?
Negative.
Negative. Something bigger than 6 I can plug in.
Yeah.
10, okay. Sure, 10 is fine. 10 times 10 minus 3 divided by 10 minus 6. Numerator, positive or negative? Positive. Denominator? Positive. So the whole thing is positive. Okay, now I'm almost done with an answer. I have to go back to inequality. Am I trying to get pluses or minuses here? Pluses, right? Right, so if you're not sure, oh, do I care about the pluses? Do I care about the minuses? You just go back to your inequality. It's telling you what you care about. It's telling you care about the pluses, right? You could have had a different problem that said less than. That means it cares about minuses. Question?
I was just answering.
Oh, in terms of the answer? Yeah, a question or answer? Question, yeah.
Is it always gonna be like negative, positive, negative, positive?
No, it could actually be like, it could be anything. I could make examples with cut points. It'll be minus, 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 minus. Just tell me any pattern you like. You like all pluses? I'll give you the same example where it's all pluses. You like minus, minus, plus, plus. I'll give you the same thing where the cut points are the same, but it'll be minus, minus, plus, plus. Yeah. So it's not like you can get a pattern out of it, unfortunately. It just depends. So like, for example, if I put like a x squared here in the numerator, cut points would be the same, but then this minus would actually change to a plus. You get plus plus. Yeah, so you can't really go on that by that, unfortunately. Okay, good question. Oh, was there another question? Let's see. What was your name? Sean?
Sean Caldwell, yeah.
Sean Cantor?
Sean Caldwell.
Or, oh, okay. Okay, and we're gonna give an answer. What's your name? Rachel. Okay. Yeah, so what's the answer? I want the pluses, so what am I gonna input? Yeah, we'll do intervals, yeah.
Bracket 0, 3.
Bracket 0, 3,
Union.
union or comma, or you could put union, which is the cup.
Parentheses 6, infinity.
Good, 6, infinity. And why'd you put parentheses and not a bracket? Right, open circle, we don't want 6, right? We can remind ourselves what goes wrong when we plug in 6. Right. The denominator is 0, so it makes the whole thing undefined. Right, so 6 can't be because it's undefined. Okay, so when you did this on WebAssign, make sure you're careful with your open and closed parentheses. It's probably something to do with that. Right, make sure when things are undefined, you're doing open. And when it is defined, you'll need closed. When it's greater than or equal to. We'll do a couple more examples, but this okay? Are there any questions on this?
So for the closed interval, you said, we talked about like setting the numerator.
Let's see, for the close interval. Yes, usually if it's coming from the numerator, it really just depends on the problem, but the numerator doesn't cause any problems. It'll just be 0. So that'll usually mean brackets when it's coming from the numerator. And the denominator, because it's undefined when it's 0, will usually end up with the parentheses. Okay. But it does depend on the problem. If the problem asks you for greater than 0, they don't want equal to 0. So if this was just a greater than symbol, you'd actually put open parentheses 0 and 3. Because 0 and 3 make it 0, you don't want it to be 0. It just depends. But these domain questions that it's related to, 0 will be included. So I'll show you an example. So try this one. So get the domain of f of x equal radical x minus 3 over x squared minus 6x minus 7. Now remember, we had the little hint, the little tip chart told us what to do in terms of if I see a radical, what do I do? I take everything inside of the radical. I can't take radicals of negative numbers. I grab whatever I see in the radical, no matter how complicated it is. And what do I set it? Greater than or equal to 0. Right? I can't have radicals of negatives. So anything inside the radical has to be greater than or equal to 0. Now, does anyone see how this is related to what we just did? You guys see how this is now related to, this is the exact same problem that we did from pre-calc. Right? The whole point of that pre-calc exercise is it teaches you how to solve inequalities, right? So to get the domain with involving a radical, we have to solve this inequality. Okay. So go ahead, take 5 minutes, try to do it. Try to do it, get the cut points, right? You'll have to factor a little bit to get the cut points. You'll have to remember how to factor. You know, and try to get the domain with the number line like we did. Okay. And I'll walk around a little bit to see. And feel free to work with your friend, you know, just get help from maybe your buddy knows. I'll come around to what people are doing.
Fireworks now.
Next. This one. Now you're going to people. You're going to test in between all the time. You're going to use this. You look carefully with the factors. Then factor.
Oh, so. Super zero is that? Means zero. Seven is greater than 8 is greater than. It makes the denominator zero. So.
Zero in the denominator. And then it's undefined.
The denominator cannot be zero because when it's zero, it's a.
Let's think it is defined. Yeah, so 3 was good, so we closed it. And 7 is bad. When it's bad, it'll be open, and -1 also will be 0 in the denominator. Exactly.
Wait, wait. Take it back. I think this is. No.
Okay, what cut points did you guys get? Let's go over it. Right, we need the numerators to be 0, and we need the denominator, which you'll have to factor. You'll usually have to do algebra and factor. So x minus 7, x plus 1. Okay. So x minus 3 equals 0. So that gives me x equals 3. And what are my other cut points? 7 and -1. See, and your name? Monica. Okay, 3 cut points. So we have -1, we have 3, we have 7. Okay, we just have to figure out if it's an open and closed circle, right? Remember, if you plug it in and it is defined and it solves it, that's a closed circle. Closed circle is good. If something's undefined, that's an open circle. That's bad. That means we don't want it. So if we plug in 3, the numerator is fine. It's 0 over something. So could we be 0? Is 0 okay here? Yeah, it's okay to be 0 because I need to be greater than or equal to 0. So 3 is closed or open? Closed. But if I plug in 7 or -1, see, it's x minus 3 divided by x minus 7 times x plus 1. If I plug in 7, what's the denominator? 0. So is that good? Does that solve the inequality? No, it's undefined. Open circle. That can't be part of my domain. It's not even defined. What about -1? Same thing. Open circle. It's not even defined. Not even defined when I do it. So something to the left of -1, let's say -2. So if I plug in -2, -2 minus 3, -2 minus 7, -2 plus 1. -2 minus 3, negative or positive? Negative divided by -2 minus 7 is negative. -2 plus 1 is negative. So what's negative divided by negative? Negative. Well, the denominator, negative times negative is positive. So negative divided by positive is negative. Yeah, so odd number of negative signs. So the whole thing is negative, so I could put a minus there. Put a minus there. Something easy between -1 and 3. 2 is easy. 0 is pretty easy. You could do 0. So now you could even do it in your head, because it's a little bit of algebra. If I plug in 0, the numerator is going to be minus. And then the denominator is 0 minus 7 is, what is it? -7, which is minus. And 0 plus 1 is plus. So I have a minus divided by minus plus, which is positive. Okay, now I can move on to 4. If I plug in 4, the numerator is minus or plus? Plus. The denominator, 4 minus 7 is negative. 4 plus 1 is positive, so negative. Here I plug in 8, so I get positive, 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 positive. Right? It didn't have to be that way, but it happened to be minus, plus again. And that's okay. Now we have to go back and figure out, do I want the pluses or the minuses? Right? The inequality tells me which one I want. So what's my final Webassign answer?
-1 to 3, and then 7 to plus 2.
Into plus infinity. And what were you going to say? Yeah, go ahead. So tell me, is it -1 to 3 open parentheses or closed parentheses on -1?
Open.
Open, right? -1 is open. 3 is closed or open? Closed. 7 closed or open? Open. And infinity, we always put open. Okay. What was your name?
Matthew T.
Oh, Matthew T. Okay. Okay, we have 2 Matthews. That's the Webassign answer. Does that make sense, guys? How to do these? So you have a couple of these on the Webassign. So you see now where it's marking it wrong? Does this help a little bit? Right? Was it a parentheses issue, closed versus open, that you had? See, Jackie? What is it? Yeah, nothing between 3 and 7, because that'll actually be negative. That's not part of the domain. Yeah, so in order to be part of the domain, this thing inside has to be positive. But between 3 and 7, just plug in things like 4, that'll be negative. And I can't take radical of negative. So that's not in the domain. Yeah, so the domain are all the good things, the non-trouble things. So the positives are the x values that I could take the radical with. Okay, so anything here, I plug in, I'll get something positive, I could take a radical. Anything here, I plug it in, I'll get something positive, I could take a radical. Anything here, I plug in, I'll get negative, can't take a radical. Anything here, I plug in, I'll get something negative, I can't take the radical. So the domain is where you see the plus signs. So I want to see the number line on the exam. Like, you can't just put down an answer, because then it's like guessing. Right? I'll have no way to know how you got it. Okay, so this is the kind of work you show. There's really no other way to know what it is. Okay, so let's do fine. So let's try another example. So do the domain of, let's see, h of t squared minus 2t minus 8. Okay, so this one's actually easier. It's going to be less work, but do it the same way. Right? We have a radical, so do it the same way. Okay. So no denominator means your life will be easier, but try it. Okay, let's see. So what's the first step? I'll call on someone that hasn't spoken yet. Vincent? Vincent here? Yeah, Vincent, how would I start this off?
You convert that to t squared minus t2 minus 8 is greater than or equal to 0.
Right, right. I need the thing inside to be greater than or equal to 0. And then what did you try to do? Factor. Good. How does it factor?
It ends up, I got t minus 4 parentheses and then another parentheses t plus 2 greater than or equal to 0.
Great. And what are the cut points?
It would be 4 and -2.
4 and -2. So then when I put it on my number line, should you make a closed or an open circle?
See, that's where
Yes, that's the tricky part. So how do you know whether to do closed or open? We'll plug it into the equation. So if I plug in -2, I get 0. Is 0 greater than or equal to 0? Yeah, it's perfectly defined. So because plugging it in solves it, things work out well. I'm going to do a closed circle. And if it was undefined, I would have put an open circle, but it's not. And if I plug in 4, 4 minus 4 is 0. Is 0 okay? That's greater than or equal to 0. So that closed circle means I do want it. All right, so closed means it's a good thing. I want it to be in part of my domain. Okay, so the rest is like we did before. Plug in something to the left. So to the left of -2 is -3. So -3 minus 4 is negative. -3 plus 2 is negative. Negative times negative is positive, so it's a positive. What about 0? Plug in 0. What do I get? Negative times positive, so negative. I plug in 5, I get positive, positive, positive. Which one do I want, the pluses or the minuses? The pluses. So my final answer using the closed circles, negative infinity to -2, or to infinity. Okay. Is it coming together, guys, like with this? Yeah. Okay, this will be very important for the third part of the course. That's why we'll focus on it now, so we don't have to go through it at the third part of the course when we're focusing on other topics, right? This is something we're really going to need. So, okay, any questions? Any algebra questions? I'll entertain algebra questions. I'm just adding, subtracting. Okay, so here's an example of just, again, we talked about what is a function and what's not a function. So again, let's practice it again. Is it a function? X equals to y squared. Is it a function means, i.e., can I solve for y? Meaning, can I solve for y? So here, I could take the square root of both sides, but if I take the square root, y equals plus or minus square root of x solves it. Okay, because put in negative rad x, you square it, you get x. Put in positive rad x, you square it, you get x. So the radicals will be plus or minus, and a function means I can only get one output, and this is giving me multiple outputs. Right, so the answer is no, not a function, not a function. Okay. When you have square roots, there are multiple answers. Okay, so just think about it. X equal to y squared. You know, if x is 4, well, y could be 2. 2 squared is 4. But what else could y be if x is 4? Y could also be -2. -2. So you can't, you're not allowed to have 2 values for a function. right? So it's not a function. What about this? X squared plus 7y minus 3 equals 0. Can I solve for y? Y by itself without multiple values. Yeah, what do I do? What algebra do I do to get y by itself? What did I do? Go ahead.
You would isolate your y, so you could either subtract 7y on both sides.
Mhm.
And then you would divide both by 7.
Good. Squared minus 3 divided by negative 7. Right, I isolated y, and I'm only getting one answer. So it is a function. One thing that we're not going to use this so much, it's less important, but there's something called the range of a function. Is set of all outputs. Now you'll see this a little bit on the WebAssign, but we're not really going to use it so much. So I'll just do one or two little quick examples. But the range of a function is i.e. all y values. Okay, so domain is much more important, but because that's the x values. The range is all the y values. So just so you guys could see the difference, y of x equal to rad x, it's hard to see the range without actually graphing it. But if you graph it, you start to see the range. This is radical x. Now, here's y and here's x. What are all the y values that get taken by this function? Like, is the y ever negative? Is it ever 0?
Yeah.
It is. That's a closed circle here. And look over here. All these y values get taken on by the function.
Opening the numbers under 0.
Yeah, so all the numbers bigger than 0 are taken by the function, right? So this function, the y values do go through everything above 0. If you just kind of stare at it, you eyeball the range. You look at the function and you see which y values get taken. So the ones here get taken, but not here. So that the range, you would write 0 to infinity. But what's even nicer, the range is y greater than or equal to 0. That way you know range is the y value. The domain though, just so you see the difference, the domain is actually just the x values. So does anyone see what's the domain here? What are the x values? 0, exactly. X is greater than or equal to 0. Right, it's all the x values you could do.
More like
Yeah, so the range is the y values, the domain is the x values. So just like another little example, just so you see the difference. So I could have a function that looks kind of funny like this. Let's say looks kind of funny like this. So the range, again, the y values, see this is an open circle, means that it's not actually part of the graph. Open circle means this y value is not taken. So 1 is not taken, okay? But what about numbers like 2 and 3? Are they taken on by the function? What about numbers like 5 and 6? Did the function ever reach 5 and 6? Does it reach 4? I'm trying to make it it's a little bit ambiguous because my drawing is awful. I'm trying to make it what's called an asymptote, that it doesn't actually reach it. It's kind of getting close to it. But basically the numbers 1 through 4 in between 1 and 4, not including 1 or 4, they are part of the range. So the range is y less than 1 less than 4. So your WebAssign, you would input 1 through 4 for the range. Okay, because those are all the y values that get taken. But in terms of the domain is going to be different, right? Because domain is x values. Just so you see the difference. Which x values are getting used in this function? Does anyone see?
1, 2 plus.
Right. What Beza's saying is 1, and then everything bigger than 1. Am I plugging in values less than 1, like -1? No, there's no graph there. So wherever you see the graph, just see which x values. So the domain is 1 to infinity. Okay. So hopefully that's enough that you guys could do that part of the WebAssign homework. We'll stop here, but I'll stay back a little if you guys had any questions or need help on the WebAssign. Come and ask me. Otherwise, have a good weekend.
And it's done our note register.
What is it? Oh, yeah, if you want it, you can take the paper. I throw them out, so anyone want it?
You're not doing parts.
It's going in the garbage. Anyone want a paper? Take paper. Go ahead. Hi.
Okay, I just have a question. I know you said like the 2 homeworks that were due today, but they're at 7. If you like send them like later on today at least, because you know it's like 5 and
Yeah, I'll extend it for this,
I'm just gonna
for this assignment.
get home and I won't have to do all of it.
Yeah, just, I'll do it for like this assignment since we're getting started. The later assignments will be due, like around.
Yeah, got it. Thank you.
Sorry.